Brakes have remained practically unchanged for the past 40 years. Conventional brakes have pads which press against the disc. These pads grip only a small area of the disc. This causes high temperatures, wheel skidding, and results in premature wear. The new floating disc brakes have two pads of friction material on 360 degrees of the disc's circumference. When the brake is applied, hydraulic pressure activates the diaphragm, which applies pressure on the pad, which is then pressed against the disc. However simple, the design of this brake called for a complex development. It all starts with a computer-aided design that has powerful software creating a virtual world of 3D images. The digital analysis submits virtual models to repeated braking to verify that the parts conform to design objectives. The software verifies changes in heat, the effects of vibration and resistance to breakage. The right choice of materials is critical. The electrical components also have to be created. Here, tiny sensors are delicately constructed which measure the force exerted by the braking system. The sensor is the main component of the intelligent ABS braking system, which functions more efficiently than traditional anti-skid systems and reduces braking distance. Then it's the fabrication stage of the prototype parts which will be tested. The machining of these parts must take into account the requirements of mass production. This high-precision machining is controlled by computerized digital lathes. A continual cascade of lubrication keeps the operation cool. The finished parts are precisely measured, then fitted and assembled to form the braking system, which will now be tested in the laboratory. These brakes have a friction surface 6 times superior to traditional brakes. The use of aluminium and composite materials allows for a weight saving of 2.5 kilos per wheel. They proceed to power and endurance tests on this dynamometer, in which a brake and wheel assembly act against the large rotating drum. These lab tests are critical, since they can detect any defect in a braking system before it's installed on the actual vehicle. To evaluate the power and endurance of the brakes in full application under extreme conditions, they're installed on a Porsche 911 Turbo, then entered in a competitive race. They proved effective, helping the Porsche to record many wins. Once all the tests are done, they move on to the next step. The brakes are installed on a production vehicle. With data systems reading everything, engineers can observe the performance of brakes under all conditions, thousands of times a second. Finally, engineers proceed with actual braking trials. Once these final tests have been approved, the braking system is ready to go into production. And that's the story of brakes, from original idea to final product.